So that concludes our opening remarks. I want to now introduce Carl Zebarth, one of our directors of Texas Rail Advocates, who's going to introduce our first section of panels. Thank you very much.
Good morning. Great pleasure to see you all here. What we're trying to do is explore a number of different areas of the railroad industry. One of them is risk avoidance, risk detection. We have two speakers today who come from very interesting backgrounds and are doing quite different things, one above the rail, one below the rail, or at the rail. Robbie Brownell of duostech comes from a long railroad background. He spent 25 years or so at CSX and R.J. Corman, and his company has perfected 360-degree inspection systems for moving trains, which is fascinating. Robert Grant, who's a personal friend, and by training he's an electrical engineer, and he's, I guess, came out of the old British Rail Derby operation, took over their subsidiary in Spain and developed some very advanced technology, which has now been implemented for about 10 years in the United States in terms of track inspection at speed. And he'll tell you about it. Their primary client is a Class I railroad, and they are developing these capabilities further. So Robbie, why don't you lead off and come up and...
Forward?
Yeah, you go to the next slide with that one.
Gotcha, okay.
There you go. You got a laser pointer.
Gotcha. Good morning. Nothing like kicking it off in the morning, be the first one here. So pleasure to be here. Thanks, Peter. And hopefully you take away something from this presentation about intelligent technology and new systems that are immersing in the railroad industry. So a lot of you guys probably do a lot of conferences, AR Research Review, different aspects where they've heard Mr. Patori, Ron Patori from the FRA speak. Want to start off with this slide. 6 key areas that the FRA is focusing on. First one is safety. Obviously, that's always important. It's what we do. PTC, we've lived that for the last countless number of years. Regulatory reform. This one just come up, and it's going to be the next PTC, sort of say, and that's crossing trespasser accidents. And that's highlighted because we were actually covering some of that. Amtrak, we all keep Amtrak near and dear to our heart. And then the technology aspect. And in relation to technology, 3 key items there that points from the FRA is 1, developing opportunities to promote safe methods for the growth. FRA has acknowledged that prescriptive regulations will do more harm than good because they can't keep up with the technology, and augmenting performance and prescriptive-based rulemaking. So it's a changing environment in Washington. You have to stay on it every day with the committees there on the safety side, and the culture. The culture is definitely changing. So obviously in today's world, we've got a great diverse group here with ranging from short lines, Class I carriers, down to Texas Central and some passenger agencies. Everybody focuses on, number 1, improving the safety, to reduce online failures. Obviously, we want more reliability for the customers. Greater productivity, and what I mean by that is work smarter, not harder, obviously, with your employees. Improve yard and network fluidity. That comes down to dwell and assets. Increase system velocity, and that may not just be on the line of road, but that could be in the shop. That could be in the repair track. It could be a number of things. And at the end of the day, you want to make it more reliable, safer, and more secure. So that's a big focus on technology. Some of the key aspects are out there, and not just duostech, but some other companies and other competitors. I know I've talked to a few folks here. A number of ways you could to do this, and through modules, which would be the vehicle undercarriage examiner that looks underneath. Thermal is now a big thing. Pantograph inspection. So that's obviously the carbon strip, making sure that any wear and any cracks. and then track intrusion or track aware, which goes to the trespasser side and the grade crossing issue. And then, of course, that's our Centrico focusing on down to one central platform. So I'm kicking it off here with the Big Daddy, what I call the rail inspection portal. We right now have 7 on the CN, 2 on CSX, 1 going in at KCS now, and a couple other side inspection systems as we speak. That's a view of one of our RIPs, or Automated Inspection Portal as the CN calls it, up in Winnipeg. And we've got a brief video here I'm going to show that the CN independently produced. Some of you may or may not have seen it. It's the first version with Scott Daniels in it. So let's give a little bit background on how the other downflow, downstream technologies emerged from this portal.
In order for us to be able to maintain our leadership in this industry, we feel it's critical that we continue to move forward. And how we will move forward is going to be different than how we have moved forward in the past. Today, there are a lot of manual processes, a lot of people looking at rail cars as they go by or as they stand in a yard, trying to identify the potential for defect. And that has worked for years, and we maintain a safe and reliable railway doing it that way.
Well, our daily tasks can be pretty challenging at times. When we do the certified car inspection, you're down on the ground, you're in the dirt, you're in the mud, you're in the trenches, you're doing a hard task. It can take up to an hour and a half, to possibly even 2. So what's very interesting about this is that we can take that time and reduce it down from an hour and a half to 2, down to minutes to seconds with a technology that is the Automated Railcar Inspection Portal.
So we're attempting to go from a completely manual inspection, where we use a human eye, to move toward a automated inspection through a portal, which automatically bad orders cars, and we get to do the repairs.
These are high-resolution cameras pointed at the train, with the train going through it at track speed is up to 60 miles an hour. So these are very large pieces of infrastructure that have very high-intensity LED lighting that light up the sides and the undercarriage of the train, and cameras all the way around, taking pictures of everything from what's underneath to the sides to the top. And we get a picture of the entire train, a picture of every single car following the locomotive is captured 360 degrees.
No matter what time of the day or night, time of year, there's no discrimination between the bad ordering of the car. So where a human eye may miss, the machine will not.
It'll capture an accident before an accident happens.
We're going to have the same eye looking at rail cars all the time, 24 hours a day, 7 days a week, and we should catch more of the defects and make it a safer railroad at the end of the day.
This isn't about replacing people with machines at all. This is about giving people the tools and the insight they need to be most effective. I can have a camera serve as a camera and look for things. I want the experienced carman figuring out what's the priority of action I need to take in this instance. What needs to be fixed and how best to address it, in what priority and what order. Our expectation is that we'll do more work on our assets because we'll find more things. I'd rather invest more time and effort fixing our equipment and our assets before they break down than dealing with it afterwards.
We'll have less carmen inspecting, and we'll have more carmen doing the precision repairs.
And so in that sense, I think it's pivotal in that it's going to start changing the way we think about the role of technology and operations within this industry and certainly within this company.
I envision what this is going to do for CN Rail and the industry overall. I'd love to see what this looks like 20 years from now, and what are we doing and how safe the railroad could be using this kind of technology.
CN saved us a lot of money with that video, but it was a good video. And a shout out to Froscher there back there with the sensor, their wheel sensors there. Big, relationships and partners are key. in the industry, as you all know, with your customers and with your vendors. So it takes a team effort. So that's basically what the rail inspection portal is made of. CSX calls it the train inspection portal, the tip. I don't know if you all see the video out there with Facebook. Number of different modules, and it doesn't just apply to freight, it applies to transit, passenger. So we can do these inspections from 0.0001 miles per hour, and realistically, you could go up to 300 or more, depending on the camera technology. So what happens there is takes images of the train as it goes through the portal at track speed and stitches them together, which allows the model, the AI model, to do the inspection. And so you do it simultaneously with automation and manual both to get to the end game, which is soon to be within the 2-3 years, an automated inspection report that comes out that will basically, the mechanical employee will go right through it like a checklist on a workflow. So one of the modules, vehicle undercarriage examiner, how many car inspectors that's in a receiving yard or location other than a transit passenger, unless they got a pit, don't crawl underneath that train. So this allows you to get that view underneath, which could capture, obviously, bolts missing on a coupler carrier plate. This is at 60 miles per hour on a double stack solid drawbar. And then you're missing that plate, a potential other plate too, that is able to save a derailment. As everybody knows, that if you have a drawbar that falls out, it causes catastrophic damage or derailment. So at track speed, good stuff, catches those hard to find defects. Some other examples of some defects with the side panorama and the high resolution cameras. These are just some basic stuff with anywhere from a dragging brake chain down to applied handbrake to a missing cut lever. This stuff is out there. You're never done inspecting for safety, inspecting for issues out there. So there's always going to be something out there to look for to make the railroad safer and to prevent a derailment or any incident for the public. Thermal imaging is starting to come around. This is actually at TTCI. We actually have two modules or two systems out at TTCI on their heavy tonnage track. We have a thermal imaging, which is a locomotive image right there with as you can see, with the return fuel line. Can capture, defective traction motor wires, leads, you name it, and if there's any other health issues with the locomotive. Pantograph. The pantograph system, this is early versions we do a 3D system. It captures defects and anomalies in the carbon strip down to 0.05 millimeter. We work with our partners at Metra and some other agencies. We're able to advance the AI, and with the imaging on the pantograph, here's an example of some of our images from that. We do simple OCR. Here's a sample of one of any container. So our company also does distribution centers with truck portals. We also can integrate that in on containers. What that allows you to do is have a seamless process, so you can eliminate any ambiguities and anything with the system. Industrial rail car inspection system, which basically is a little bit downward or a little bit more of a lower type rail inspection portal system that can fit the industrial railroads or industrial companies out there, like Flint Hills is one of our customers for inspecting tank cars on a manual basis and also on an automated basis. So if they're focused on tank car hatches, on missing hatches for pellet cars, so on and so forth, and also side images for inbound cars to prevent them from going to the rack to load and to save time. The key thing is also we have a user interface, and with any system, you always want a friendly user interface that allows you to integrate other aspects in reporting. We take any AR standard and any FRA standard on the CFR 49 regs, and we can integrate those into any system, so it's a transparent workflow down to the mechanical teams. That's the key thing. Is it's like telling that secret to the next person down the road. What originally started like this may not be this at the tail end, and so you want to ensure that nothing slips through the cracks. So the next one is our intelligent right-of-way system, what we call TrackAware. As you all are aware, right now there's a big presence or big push on eliminating trespasser fatalities and grade crossing accidents. The top 3 states in the United States that are on the top of the list for the worst number of incidents: 1, California; 2, my home state in home state in Florida, and 3 right here. Actually, Texas is number 3 in the United States. So funding is allocated through the highway system to the states for an upgraded technology to help with prevention of trespasser and grade crossing incidents. We have a system that also does virtual fences, has multiple zones. We've got a lot of data scientists and a lot of programmers and some really smart people that do nothing but ground truthing and design and code this stuff. We can do object classification, object tracking, you name it. We can see it, we can do it. Right now you're being watched anywhere you go in this world with cameras everywhere. Here's an example of one of our handheld cameras up in New York, up Lexington Avenue. It's identifying a woman, a man, umbrella, car. It can instantly, once you start feeding that model, the AI, it can actually determine who, what, where you're going, what type, at any given time. You're being watched. And imagine what else is out there. So you take that, if we can harness these technologies, apply them to elimination of trespasser incidents and, basically vehicles stopped on grade crossings ahead of time and integrate that into to the warning system, it's huge. And right now we're actually working with FDOT with the pilot system and have worked with other states to help develop this. So we also did a test up in New York City, and actually it's NYCT up at 50th Street. NYCT originally, they called us liars. There's no way your system's 100% accurate, and it was. We had the data to back it up. The key is proper pixeling on the target for the accuracy of the human detection. So if you have this type of quality camera here that's blurry, and this type of camera that's really high resolution HD that can capture it, your output from your AI and your model is going to be significantly more accurate. Our system can distinguish the difference between a person falling in there and a roadway worker. It can also do people counting, getting on and off the train. So this is an actual video. Let's see if it starts here. That was a video of actually a gentleman there. I guess it didn't play, did it? Let's see. So there you go. Click. All right, well, anyway, so in this case, this gentleman fell into the, going back there, this gentleman actually fell into the right-of-way right there in the actual video of that. And he actually did live, New York City, there's a subway, peak times. Many of us probably have been up there. I know I was just there back in November. They have an average of 45 to 50 plus deaths a year with people like this, doing stupid stuff, falling in there. And of course, that guy was obviously intoxicated. Excuse me. So here's some more data to, I'm a big data person, the numbers to back it up. 73% of grade crossing accidents or trespass fatalities and accidents happen within 1,000 feet of a grade crossing. This is data from the FRA that just recently come out to the report to the United States Senate. 73%. So within that zone, our system can actually detect the difference between a human being, a ball, a cat, a dog, and send alerts to the OCR, and do audible messages via the radio to the oncoming train if there's one on the approach, and also with cars stopped in crossings that for a particular length of period, or even when the gates come down near high density intersections near railroad crossings. Florida statistics, the top incident rate for grade crossing accidents is cars stopped on the track. Not because they broke down, not because they bottomed out, it's because they're near their highway grade crossing, railroad crossing near I-4, near areas where they come out, and it's between the hours, obviously, between 3 and 6, when people are going home, when people are coming to work, so on and so forth. Example of one of our zones that we set up with the right-of-way system. The basic one, we actually did this out on the West Coast with Metrolink. We also do tunnels and other significant assets. We're able to do OCR and AI video analytics of people going into tunnels, other assets, areas where they don't need to be, and we can track them in and track them out. And it's all done along the right-of-way, processed right there. Example of one of our Raspberry Pi cards that is really simple, seamless, and cost-effective. It's not one of these out-of-the-ballpark areas we have to integrate with PTC or anything of that nature. It's a cost-effective solution for folks with our vendors that they're looking for. So development of algorithm mapping, you're probably thinking, how's the FRA going to accept all this? Well, one, you got to improve the confidence level and get that trust factor. One is the performance statistics are huge, making sure that you keep it accurate rates, and make sure your low false positive rate is where it needs to be. Your consensus data is also where in line. And also document it from start to finish. That way the FRA knows where you started, what changes you made, and what your outcome was, and if it's satisfactory to the accuracy level of 98% or better on the AI detection. So in this case, we developed an algorithm mapping sheet that basically coincides. This is actually one of the original ones we worked with on the CN that shows what we did and the model validation. So that way you've got some documentation to support your AI. It's not something you just pulled out of the sky and plugged in. Example of the platform chaining. So when you do AI on rail cars, obviously you start out with this and you end with that, and the outcome of the detection may involve 2 or 3 other algorithms within that detection or that model to get to the outcome. You feed it into the model, the system grows within a matter of weeks or 2 weeks. You can have an accuracy level of 90% or better. We can tell the difference on an OCR and a plat card, read it, and then know what type it is. And of course, what are the end results? Obviously, number one, safety, all the way through to dwell, capacity, other items with any technology out there this day and age. It may not be ours, it could be other technologies that are out there, but that's the key, is safety, and then the end game, which is ROI. ROI for the freight railroads, obviously, which is your immediate return on investment. And then on the transit agencies, as you know, it's value. It's reliability, providing a service to the public, and ensuring that the tax dollars are actually being well spent and actually being used on the accuracy of the reliability of the service. And finally, here's an example of any technology on the outcome. Our partners at CN, the rail inspection portal, the value savings on technology, right there with Winnipeg is $4.1 million, and we're working with some other partners in the industry as well, CSX, KCS right now, to take the railroads to the next level and integrate with their systems and install ours to offer that. And that's really what a lot of the railroads and the public is looking for. Thank you.